So let's continue. Basically, as mentioned just now, the solid uh, ground curing process. You make a photomask first, and then you put a layer of a photosensitive polymer on the surface, and then put the photomask on top of that particular layer, and the UV lights from the top. So then basically whatever lights that the photomask let through will hit the surface of the photosensitive polymer and get cured. Whatever didn't get the light from the UV light, because it's being blocked by the photomask, will not be cured. Next process, you vacuum the uncured photomask, right? And then next, basically, you put a wax. So once wax harden, then basically you have to mill the wax and also the photosensitive polymer that hardened just now, so that you can get and control the layer thickness that you want to make, right? So that's basically the principle and the process of this SGC, a solid ground curing process. So there might be some secondary operations that's needed. One is to remove the wax. So to remove wax is very easy. You just put in an oven and then just melt away. The wax matrix make it unnecessary to generate extra support structure for the overhang and undercut. So because of that particular wax, then you don't need to have a support structure. So this is examples of the process. So this is UV light source. So this is a photo mask. So whichever area that's being blackened by the photo mask. So this is printed on the mirror. So whatever light. Siapa yang ada background noise tu tolong mute kalau tak saya mute semua. Right. So basically, then this elevator or support system will go will move in the Z direction, right? The advantages and disadvantages. Basically, complicated and large component produce no need for additional support. So again, for this particular process, you don't need additional support because once you vacuum the unused polymer, then you put wax around it, right? So because of that wax, then basically whatever overhang on top of it will be deposited on the wax. So you don't need this additional support system. You don't need a post cure for this particular process usually. So multiple parts can be run at the same time due to the large workspace. So the workspace is large. It can be large because it's not limited to the movement of the, let's say, laser head. Let's say, for example, on other process that we went through, the laser head need to move to the area where you want to fabricate the parts, right? For this particular process, you don't need to do that. Basically, once you make the photo mask, you shown UV light through it, then basically that's it. There's no X and Y direction movement needed to fabricate the parts layer by layer. Accuracy is good, part complexity does not affect the speed. So part complexity does not affect speed, but volume does. So the part complexity does not affect the speed because the process is done at one go for that particular layer by shining a light through a photomask. That's about it. But volume does. So if you need bigger parts, volume in terms of the Z directions, then it will increase the time. Right? Weight may be inserted at any time to alter the center of gravity. So that, for example, if this part required is out shape and you want to make sure that you have a center of gravity is located at certain part, basically you can insert a weight for this particular process. So you can put, let's say, for example, some weight so within some of the process. You can put weight in anywhere on the parts before next layer being formed. Yeah? Layer can be milled off if they are found to be an error. So if you make a mistake for this particular process, since there is a milling operations to ensure the thickness of the layer, right? So you can, if you make a mistake, then you can mill off that particular layer and also and then make a new layer. So that's basically advantages of SSGS. Some of the disadvantage, equipment cost is quite high, and usually the machine size is large. So space requirement is need to be think of. Process is rather complicated and quite high maintenance and skills provision. So we have a milling process, we have a photomask manufacturing process. So this is something that you need to pay attention. Range materials is limited because this can be fabricated using material that is photosensitive, right? Can react with the photo. Wax must be removed after production in large oven, so there's a post processing. You have to remove the wax. Process is noisy. Process will be noisy, so you have a milling operation, so on and so forth. Then the process tend to be noisy. Overexposure of polymer may increase the viscosity and make it unusable. Thus, greatly increase the volume of expensive polymer use. So overexposure of polymer. So you have to remember, the polymer in the process itself is very sensitive to light. So if there is any overexposure of a polymer to light, then basically it will increase the viscosity and make it unusable. So this is something that you have to, that during the manufacturing process, this needs to be taken care of because you have to control the exposure of polymer to light, and this can be quite tricky. The resin required a light sealed chamber and toxic material handling procedure to be used. So again, the resin or some is the resin, which is the polymer, required a light sealed chamber. So you need to have a chamber to ensure that the polymer is not exposed to light. If it's exposed to light, then you're going to change the characteristic of the polymer, the viscosity, so on and so forth, and you might not be able to use it anymore. And there's some toxicity on the material due to evaporation of certain solvent during storage process. So those are some of the advantages and disadvantages of SGC. Any questions? Okay. If no questions, okay. So the next process I would like to share with you is the 3D printing. 3D printing process is, I think by now you have heard about 3D printing process, right? But sometimes we use 3D terms in general. No, whatever AM process, we call it 3D printing, which is actually not accurate, So technically, if you refer to 3D printing process, then this is the process. This is the process. So this 3D printing process start by depositing a layer of powder material on top of fabrication chamber. So first, so there are two chambers. So this is similar to ground curing process. So you have two chamber. You have powder delivery chamber and fabrication chamber. Fabrication chamber. The only difference between this process and the ground curing process just now, solid ground curing process just now, the curing of the material is done through UV light, by UV light. But in the 3D printing, the curing of the materials is based on the injections of adhesive, liquid adhesive. Okay? So the bonding of materials is done using is adhesive. Okay? So the process starts by depositing a layer of powdered material on top of the fabrication chamber. So again, just like a solid ground curing process just now, you have two chambers. One is powder delivery, one fabrication chamber. Simulating. Accomplishes by a quantity of, by a measured quantity of powder is first dispensed from a similar supply our channel. So this is similar to the way the material is dispensed on the part chamber is the same as solid ground curing process just now. So the only difference is on the curing itself, where you have multi-channel jetting head, subsequently deposited liquid adhesive in the two-dimensional pattern onto the layer of the powder, which becomes bonded in the areas where the adhesive is deposited to form a layer of the object. So over here, you don't use the UV curing, but in this particular process, you use liquid adhesive. So this inkjet head actually dispense the liquid adhesive for that particular layer so that the material can bond together. Once layer is completed, the fabrication piston moves down and thickness of the layer, by thickness of the layer, and the process repeated until the entire object is formed. So similar to the ground curing process that we mentioned just now. You have this powder in here. So whichever area does not get in touch with the liquid adhesive will be in powder form. So again, this particular process does not need a support system. Okay. This is the schematic of it, illustration of it. So basically, you have So this is in the middle of the process. So this part has been formed. So this is a powder. So the roller mechanism basically put a layer of a powdered epoxy on top of that particular parts that's being manufactured. Right? And then the inkjet head will dispense the binder, the adhesive, to whichever parts that need to be formed. So once that's done, then basically piston will move down, and then you repeat the process until you make the parts. This is a finished product. After completion, the object is elevated and extra powder brush away, leaving the object. So again, you still can reuse this excess powder. And again, like the solid ground curing process, you don't need support for this because the powder bed support any overhang that you make. So if it's ceramic parts, then usually you need to cure it post processing to 1500 Celsius. So this is fully cured. Some of the advantages is speedy fabrications and low material cost. It is probably the fastest of all RP product methods. So basically, 3D printing is one of the fastest. Is the fastest rapid prototyping or additive manufacturing process. Right? Recently, color output has also become available. However, there are limitations on the resolution, specification, so on and so forth. The closest competitor is FDM. So recently, you can actually put different color on different parts of the product. So this is basically dictated by the adhesive that you put in that you dispense on the parts. Any questions? Okay, next process is called laminated object manufacturing, LOM. So basically this particular process is quite interesting. It's quite different compared to the rest of the process that we went through just now. Basically, there's the solid physical model made of stacking layer of a sheet stock, each an outline of the cross-sectional shape of the CAD model that is sliced into layer using laser. So the starting parts for this is not liquid, is not powder, but actually a sheet. So the starting materials for this particular process is actually a sheet of paper. On top of it, then you have materials uh, attached to that particular layer, sheet of paper, right? That consists of maybe plastic, cellulose material, or fiber reinforced materials. So this material is the materials that being fabricated into the parts. So the process is basically the paper is unwound from the feed roll onto the stack and first bonded to the previous layer using the heated roller, which melts the plastic coating on bottom side of the paper. So on the bottom side of the paper, it has a plastic coating. The profiles are then traced by an optic system that is mounted in X and Y stage. So the profile that you want to manufacture depends on the CAD, CAD 3D CAD model that you have. So you have a laser that move in X and Y directions in horizontal directions. So this is the paper. So this is the take-up roll. So this is the dispensing roll. So basically they move in these directions, and layer by layer of that particular product is manufactured using this particular process. After cutting, excess materials in the layer remains in place to support the part during during building. So basically, the excess materials, so for example, the cut off for this in terms of spare form. So the part is traced by the laser. So the excess material is remain there, right? After the laser has cut each profile, the roll paper is advanced. A new layer is glued onto the stack, and process is repeated. After fabrication, some trimming, hand finishing, and curing is needed. So you need to do some trimming to remove the unwanted parts of the sheet, and so you need some trimming, hand finishing, and curing of the parts. Again, for this particular process, you don't need to have a support structure, because the part block of unused portions of the laminated paper is there, so that any overhang that need to be manufactured on top will be manufactured on that particular unused part of paper. So basically, as I mentioned just now, it's a self-supporting for overhang and the cuts. You don't need to have a support structure. So area of the cross sections we need to be removed in the final object are heavily cross-hatched. So whichever area that's not, let's say for example you make this part, right? The one in white color. So this dark color is not needed. So what happened is during the process, the laser will cross-hatch these particular parts so that it become weak and easy to remove later on. The surface finish, accuracy, and stability of the paper objects are not as good as material used in other end methods. However, material cost is very low. So material cost in this particular process is very low. An object have a look and feel of wood and can be worked and finished in the same manner to form pattern for sandcasting. So usually the parts that's been manufactured using this particular process is the feel is like wood, and usually it's not I mean, it doesn't have much strength to it. Usually, it can be worked and finished in the same manner of a form pattern for sandcasting. So, if you for sandcasting, if you want to make a sandcasting, you have to make a pattern, right? So it's similar to that. While there are limitations on the material, work has been done on plastic, ceramic, and metals. These materials available on the limited commercial basis. So if you look at this particular process, this is examples of the parts. So every single layer is actually process of the sheet paper itself, right? So this is supply. This is the uptake. So that cutting the parts to the profile that's needed based on the 3D CAD modeling. Siapa yang ada background noise tu boleh mute. Ada speaker. Okay. So this is examples of the
Kementerian Kesihatan sedang meneliti peluang mitigasi atau pengurangan bagi memastikan rantaian COVID-19 diputuskan selepas Perintah Kawalan Pergerakan.
Okay. So this is examples of the parts that manufactured using this particular process. So any questions with regards to laminated object manufacturing? So next is called multi-jet modeling, MJM. So in MJM, multi-jet modeling, the printer head comprised of 96 jet oriented in the linear array built models in successive layer. So this is basically MJM multi-jet model. It has a head, printing head, and in that printing head, it has 96 jets in array. So this is example like dot matrix printer, the old dot matrix printer. So each jet applies a specifically developed polymer materials only where necessary, and the polymer is cured instantly by UV light bulb positioning alongside the jet. So the process is quite simple. This is a platform. So you dispense the materials on where is necessary, and alongside that particular head, there is UV light bulb. So as it's printing and move, basically the UV light bulb will cure that particular polymer. The MJM head shuttles back and forth like a line printer, x-axis, building a single layer of the model as thin as 16 microns. So it'll move it in the x directions to make that to dispense the polymer for that particular layer, right? And cure it. And it can be as thin as 16 microns. If the point is wider than MJM head, then the platform reposition in y directions and continue build. So basically, it moves one directions like that in x directions. Let's say, for example, the parts is the width of the part is more than the width of the width of the printer head itself. So then it needs to index in y directions and move in x direction. Index in y direction, move in x directions. So that it can manufacture the whole layer. Manufacture the whole layer. So that's what it meant by this. If the part is wider than MJM head, the platform repositions in x in y directions to continue building the next layer. So if the parts is wider than the head of the multi-jet head, then basically once it moves in x direction, the platform will move in y directions, and subsequent subsequent profile can be manufactured by the jet. Okay? So the process continues until the model is completed. A large number of jet allows fast and continuous material deposition for maximum efficiency using expensive polymer. So since you have 96 jets in array, then basically allow for fast and continuous material depositions. So efficiency can be high. And that the thermopolymer also inexpensive. The resin for the support is made of soluble gel-like resin that can be removed using aqueous solution. So you can have different materials to supply a different jet head. So you need to have a support structure if you have overhang. So the support structure will made from soluble gel like resin that can be removed using aqueous solution. So once the product is finished, then basically you can remove the support by immersing it in the certain solutions. So the gel-like resin will be dissolved. So those are basically the type of different type of additive manufacturing techniques that's available for us to use. Um, and there are many more, but these are the things. These are the techniques that we're going to cover. So, any questions so far? Okay, if no questions, then basically economic considerations. So before anybody wants to embark in implementations of AM process, two main things that need to be considered. One is the total cost of acquisitions and also operations, because the acquisitions or the procurement of the equipment is quite high, and the operations sometimes require certain special skill. So this need to be considered. Cost system range from 30,000 to 800,000, and the total startup itself, can go up to 1 million. So investment in capital, equipment, and also setup is quite substantial. There's also hidden costs that need to be factored in on the labor capabilities uh, uh, that need to be taken care of, because you might require people that has certain capabilities and expertise. So you might need to train your workers or get a new worker that has those capabilities. Material costs can be expensive, and especially in terms of waste, scrap, inventory, and material conversion. So this needs to be taken care of. You might require uh, additional equipment and expertise also at the front end, also back end. Front end in terms of designing. Uh, so you have to create first the 3D model, 3D CAD model. So you're talking about software and also hardware to do that, and expertise to do that. Repairs and maintenance are quite expensive for RP rapid prototyping of AM equipment. So you have to take this into considerations. You might have to train your technicians of a new skill and knowledge for this. Cleaning and finishing can be tedious and time consuming and may require special tools and equipment. So this is a post process. So we have another 10 minutes to go. So I think we can finish up within 10 minutes. Toxic materials need to be taken care of. And second things that you have to think about this is the difficulty of proving return of investment. So these are the two considerations, economic consideration that to be taken care of. Challenges, general challenges in AM, part accuracy, because of the staircase appearance. So because this particular techniques, fabricating the parts layer by layer. So no matter what, you're going to have this staircase appearance for the sloping parts due to layering. And there's also going to be a shrinkage and distortion of the AM parts, especially for those that involve temperature, high temperature. So these are the things that you need to consider in terms of part accuracy. The other thing is basically the materials. So all these process require special materials. So because of that, then basically this need to be considered. Mechanical and performance of the fabricated part is limited by the material that's we use in the AM process. The rest of the material is basically some tables in terms of characteristics of additive manufacturing technology, mechanical properties, so on and so forth for you as a reference. So any questions? Any questions? Ada pertanyaan?
No, sir, semua okay.
Okay. Okay, so if there's no questions, then basically I'm going to set another session next week for next topic. I think next topic, I'm not sure what's the topic. But it'll be another session. So next week will be what? 28 last day of the PKP, and then see how's going to be what's the decisions, what's the next decisions, whether we get to have class or not after that. But the way I look at it, most probably we have to keep on doing this e-learning concept. So again, after this particular ni ada quiz. Please attempt the quiz. And there's a video attached to the ULearn. So watch the video. And if you have any questions, then you can send me send it to WhatsApp ataupun Telegram. Any questions? Any other questions?
Sir, bukan
Okay.
quiz tu kita dah buat ke minggu lepas?
I think ada new quiz. So minggu lepas ada satu quiz. Pergi ke ULearn for this week, for week 7 ada another quiz. Yeah? So attempt that quiz also. Boleh? Any other questions other than that? Okay, kalau tak ada questions, then kalau tak ada questions, then basically stay safe, selamat berpuasa. So tak boleh keluar rumah ni, puasa tu lagi elok kot. Kualiti puasa lagi elok kot this year. InsyaAllah. So that's all. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh. Selamat puasa. Stay safe.
Waalaikumsalam.
Thank you, sir.
Thank you, sir.